So hi friends, so this lecture is been meant to explain you about the hydraulic gradient line and total energy line. So this concept is being used to find what is the total amount of energy that is been present in a fluid and what is the total amount of energy that is been present when the fluid flows at any given point. So if you need to find what is the energy at any given point in a fluid flow, this graphical representation gives you a clear picture of the amount of energy available at each point. Okay, right. So to be more precise and practical, so these hydraulic and energy gradients are used to find energy that I will said already. So for example, if you're gonna lay out a pipe connection on a panchayat or a village, so you'll have a overhead tank. Okay, so you can build the overhead tanks at a few meters high, right? So but it is not like any assumption of building the overhead tank at certain heights, right? So if the fluid has to flow to certain range, okay, or certain distance, then the potential energy that is required can be calculated. Okay, so that's how the height of the overhead tank actually been determined. So if the height is very less compared to the total distance, probably what happens at the end of the pipe connection, the pressure will be very minimum. That's how you see the water that comes out from the tap will be much slower rate. Okay, because it doesn't have any energy, kinetic energy will be almost lost. Okay, so these losses we know that will be due to major loss and will be due to minor losses, right? So when the pipe has to, when the fluid has to flow in a pipe from overhead tank to each individual houses, probably there will be n numbers of pipe connections. So maybe pipes connected in series of different diameters, or you will have pipe fittings, okay, and a few more the minor losses. Okay, so then probably there will be energy loss. So this graphical representation will be useful to find what is the amount of energy that is being present in a fluid flow at any given point. So we're going to have the two different energy lines. So one will be total energy line, what is the total amount of energy present, and second one will be the hydraulic energies. So only the total present of hydraulic energies. So total energy will be, as we know from Bernoulli's, the total energy present in a fluid flow will be pressure head, kinetic head, and a datum head. Okay, so this will be the total amount of energy present in a fluid. So hydraulic gradient will be the summation of pressure head and total head, the datum head. Okay, so let's get into the more detail. So here we have a few examples from a tank. The fluid tends to flow in different sets of pipes with different sets of minor losses also. This first line indicates the total energy line. The second line indicates the hydraulic gradient line. So the difference between these will be the kinetic head. So you know the total energy line will be pressure head, kinetic head, and datum head. But in the hydraulic gradient line it will be pressure head plus datum head. Or we can call it as hydraulic gradient line will be equal to total energy line minus kinetic head. So this kinetic head. So if you minus V2 square by V square by 2G. From the total head we can able to find the hydraulic gradient line, how does it actually flow. So we will see some sample problem, then you will understand much more clear. So thank you for watching guys.